Dear viewers and subscribers, welcome again to our YouTube channel Max the Service. Please subscribe and press the bell icon to receive all notifications regarding any video we are uploading on this channel. Dear viewers and subscribers, welcome again to our YouTube channel Max the Service. Please subscribe and press the bell icon to receive all notifications regarding any video we are uploading on this channel. Dear guys, I hope you are well and welcome back to Maxi Service. And today we will discuss, revise what we have learned till now, and we will check what are the challenges and what are the benefits we have been learning and what actually we are going to learn and what we have learned. Okay, so from the start, we started with Docker uh, engine and we understand what is Docker, how Docker engine works, its architecture. Also, apart from it, we went with Docker desktop where we can see, manage, and monitor our containers. So first, from the start, we just we worked on what is Dockerfile, and we made some configuration in Dockerfile, and we build from Dockerfile or Docker image, and then we run this image as a Docker container. So here was one file, one image, one container, single host. It's mean on a single node you can do this. Just you need to install Docker and you can start working with containerization, Dockerization your application. So how to configure, manage more than one container on a single node? Uh, we also learned that if there is more than one applications which we want to run them in different containers, let's suppose we have hundred of application and we will be working with 100 files, we will be managing, we will be monitoring any change relevant that we have to take care, okay, which Docker file have to change, have to again build and run container. So is it possible to run more than one node on a single server as well? Yeah, you can run more than one Docker engine on your single machine. But how to run and build more than one container on a single node? So this was very critical and very challenging. And then Docker provide us Docker Compose. Docker Compose, it is the revolution of Dockerfile, where we can manage, we can configure, we can set up more than one images within a one file, and that is a Docker Compose. Okay, in this file, in this Docker Compose files, you can see that I can mention, okay, first I have to build this image and run as a container, then I have to build this image, okay, and then I have to run this container. I can also mention that it should be dependent on the rest of like if we have front end, it is UI which is dependent on backend. We have also done in our previous videos. You can also watch all those videos, practically examples and explanation. And also we can just tell a Docker file, okay, please do the read file, Docker file, build image, and also run container. And also it's a beauty of Docker, it's locally check with locally, if not available then it pull from Docker hub. So all of this I have explained you. Again, this is a very good feature if we can manage and run more than one services within a one Docker Compose file, instead of managing and monitoring, configuring separate image for separate service. So I can do in a single file. Okay, so what are the challenges? Here you can see we have one file, more images, more containers. If there are 100 images, we can run 100 containers, also on single node. But the limitation again is single node. Yes, you can install more than one a Docker engine on your single machine, and but you have to manage Docker Compose per single machine. If you can also have more than one Docker Compose, you can also have more than one Docker Compose, but all those will be running on single machine. You cannot run one or more than one Docker Compose file across the system. If you have 3 nodes, 5 nodes, then definitely on each node you have to take care for Docker file, Docker Compose. Okay, the challenge, what if a single node or machine goes down? Ooh, if it goes down, then what will be happen? All the services running in this machine will be destroyed, will be stopped. So application will not be available more longer. What if we want to manage group of containers across multiple nodes? Let's suppose I have one Docker file or Docker Compose file and one node, and another node and another Docker Compose file. Okay, then how I can manage? Definitely, as I said, I have to log in and monitor this. Then I have to monitor and manage this separately. At a time, I cannot monitor and manage all these two systems simultaneously. Definitely, we will be running on Docker engine on this machine as well, on this machine as well, and here as so. So we have 3 servers, I mean 3 node, but every server, every node must have a Docker Compose file, maybe single Compose file, maybe have hundreds of Docker images and running container, but I cannot monitor from this machine to this machine. If I'm login and sitting in this laptop or server and I want to configure anything on 2 or 3, then it will be not possible. For multiple host nodes, we need load balancing, scaling, and high availability. Because if there is okay, one UI, and user is accessing this UI, and you definitely you might be routing these traffic to this machine, and you might be routing traffic to this machine, and you might be routing some traffic to this machine. And let's suppose we have also deployed similar application on machine 1, 2, and 3. Then definitely you cannot do this within a Docker Compose. What else can help us to do all of this to facilitate this? And that is a Docker Swarm. Docker Swarm will be working like, let's suppose we have a cluster of, I mean group of your containers working, running on this host number 1, okay, and this is your host number 2, and this is your host number 3. You have some services running on this host number 1, some services are running on host number 2, and some service running on host number 3. Then how we can configure, how we can manage, how we can monitor all of these, this there is only Docker. Okay guys, so this tutorial is very important because we are going to learn Docker Swarm, and Docker Swarm is our requirement to manage more than one containers running on different machine or even one machine. When we run in a cluster mode, definitely there is a mechanism of orchestration, and we need Docker Swarm to overcome it. Actually, mode lets you create a cluster or one or more Docker engines called a swarm. Swarm consists of one or more nodes. Those nodes can be physical, virtual machines. Even you can go on clouds. You can use the AWS, Azure. Okay. So in this diagram, you can see first we have to understand how the structure or architecture of Docker Swarm works. Here you can see there are manager and worker. Actually, these are nodes. One we have manager node, another we have worker nodes. The duty of manager nodes is to maintain cluster states. Okay, here is the DB of states which maintain their state, and these manager nodes communicate and keep syncing with each other. These are responsibilities to scheduling the services, serving swarm mode, whatever HTTP request from CLI. What we have CLI. What is CLI? CLI actually a Docker commands interface. So from here, whatever we get any API or query, but when a user execute a command, it comes to the manager node, and manager nodes responsibility to manage all of this using raft is algorithm implementation. Manager nodes, these manager nodes actually maintain consistent internal state of the entire swarm and all services running on it. For testing processes, it is okay to run a swarm with a single manager. If the manager is a single manager swarm fails, your services continue to run, but you need to create a new cluster to cover. Okay, actually, you can also, for testing purposes, you can also create single, only one node manager. But remember that in this case, if this one manager, if you have one manager and it's get fail, then you have to recover or recreate a new cluster. But your services will continue to work. Okay. For fault tolerance features, actually recommended approach is to use odd number of manager. I mean 3, 5, 7. Okay. Actually, a three manager swarm tolerates a maximum loss of one manager. Let's suppose if there is one manager crash down, other two will be working for each of backup. So these will be synced to maintain the state, to scheduling the services, everything. A five manager swarm tolerates maximum simulation of loss of two manager. If you have five and two are down, that there is no worries. Okay, so odd number is recommended. Okay, now we have another nodes. These are worker. Okay, actually they don't work with the Raft algorithm. Okay, actually when we execute our application, we run image as a container. Here our application start running. This manager is to just manage your services, scheduling task, everything. But when you start a worker node, then definitely you have to assign an image, and here in this worker node, your image as a container will be running. Okay, important thing is you cannot have worker node without manager node. Okay, if there is a manager node, then you can have worker node. Without manager node, you cannot have worker node. Another important thing, you can promote this worker node to manager node, and you can depromote this manager node to worker node. This is important thing we have to know. Okay, let's suppose we have less manager nodes and we have many worker nodes, then we can promote any worker node as a manager node, but the responsibility and management will be changed accordingly. Okay, another important thing, uh, if you don't want to allow this manager node to assign any task, to schedule any service, then you can set this manager node into a drain mode. Because when it will be drain mode, it will not managing any services, it will not assign any task to service, because it create a service object and it also assign a task to that object, and that this worker node also get an IP address where that service get running. So I will show you in another diagram in detail how this works. Okay, guys, next is how service work. Definitely, when you create a service, there must be an image already built, and you want to just run that image as a container, and that will be a service. Okay, and when you create a service, you specify which container image to use, and which commands to execute inside the running container as well. You also define option for the service include like port, overlay network, I mean network type, CPU and memory limits, rolling update policy, number of replicas. Here you have number of replicas 3. Whenever you create a service, you can define, okay, I have number of replicas services, because whenever your one node is down, other will be up and running. And this swarm manager will work as a load balancer. Okay, guys, it is very important to understand when we create a service and a swarm manager, swarm Docker swarm manager receives request from CLI or any API call to create service. Okay, and how the service create request accept. When I create service, how the swarm manager accept the request, schedule task, and to worker node. Okay, so this is the flow, very simple. Whenever Docker create service, run this command, accept command, and create a service object. Okay, this is API for this. Now object, service object is created. After that, reconciliation loop that create task for service object. There another task is created for that particular service you created. Okay, then definitely you must run this service as a container on some worker node. Okay, in last diagram we see that there one worker node. Every worker node is a separate system and must have IP. You might have a virtual machine, you might have uh, uh, a whole system, but that must be assigned an IP. Whenever an task is attached to that service object, then allocator assign IP address to the task. Okay, this is a task to be run on 1.9.3.5, 1.4.3.2. So this is the IP. Let's suppose I'm just putting an example. Let's suppose we have IP of worker 192, sorry, 192 dot 168 dot 0 dot 1. Let's suppose this worker, uh, this node, worker node have IP 192.168.0.1. The allocator will assign this task to this IP. Okay, please take this service and run on the this worker node. Then it dispatch, it release the task to the nodes after assigning IP. If there is a worker node pending in pending state or not available, definitely you must have a Docker Swarm have a load balancer. It will go for another node. Okay. So after that, once IP assign, it is assigned task to that node. Then it will instruct worker to run a task. It will schedule if already it is running some task. Then definitely it will go and run another task with another node. Okay, then what worker node do, it connects to dispatcher to check for assigned task. It's responsibility to check with scheduler, okay, is there any task I can run, it will be connect with the scheduler. And then executors, it execute the task assigned to worker node. So this is very simple to understand how service is created, how the task is assigned to the service, and etc. Guys, there are two types of deployment services. You can deploy services in two types, like one is replicated, another is global. Here you can see there are three services replicated, 1, 2, and 3. And this global service is not replicated. Actually, for replicated service, you specify number of replicated server. Let's suppose you have a one service, you are creating a service, and you can specify number of 3, 5, whatever number you want to mention. And all those services will be serving the same content, same purpose. Okay. You decide to deploy HTTP service with 3 replicas, each service same content. A global service, okay, here black dot is a global service. Actually, service that run one task on every node. You can create global service on every node, only one global service, and it will be serving one content, one purpose. Okay, there is no pre-specified number of tasks for global service. Each time you add a node to the swarm, whenever you create a worker node in the swarm, okay, the orchestrator create a task and the scheduler assign the task to the new node. Okay, this manager node will create a scheduler task and this will be assigned to the new node. Okay, actually good candidate for global service are like monitoring agents. You want to run a global service just for monitoring agents, there is a antivirus to be running every day, or other type of container that you want to run on every node in the swarm. Okay, so in this session we have covered architecture components and I have explained you in detail. I hope you have enjoyed, and here are the key points which we have to remember what we have learned. Just I'm okay. So just to recap the key concept, let me elaborate in a detail again so that we know again everything how it works. So first of all, we discuss node. Okay, actually a node is an instance of Docker engine. So don't get confused that this node or this node. Definitely these are the kinds of node, but one is manager and other is worker. But remember that even when you have your local machine, okay, and you have your local machine, and in this machine you deployed a you are running Docker, then this your local machine becomes a node. If you created EC2 instance, okay, on EC2 instance uh, on Amazon, okay, you created EC2 instance on Amazon, then definitely there you must run Docker container, sorry, Docker engine, and that become again a node. So this is very simple term. Because mostly for beginners it some kind of confusion what is node. So node is a if you have if you are running 10 instance 10 Docker engine, then you have 10 node. Okay, so which can be either a manager or worker. You can later you can configure create a node as a manager or worker. So how manager works? Responsibilities are for the managing swarm. So this is total your a Docker swarm. Okay, so the manager node is responsible for managing all of this, also making decision about the cluster. Let's suppose you have one cluster deployed on node 1, and you have one cluster running on node 2. So all the responsibility will take care by this node manager. It is the responsibility, third responsibility is scheduling services. It also schedules service. Okay, there is a service to be run on worker which node. So 1 2 3 it will decide manager node. So I have new service to run as a container. It will assign a task, assign a IP address, allocate, and then dispatch to okay task ABC task. Okay, go and start running. This node is available for you. Okay, it is also handle API request whenever we get receive request from command line interface of Docker command line interface CLI or any API we are calling it directly connect to the manager node and it decide okay what should I do with that request. Okay, then we have worker node. It execute task assigned by manager node. Okay, worker node does not participate in the management of swarm. It's a just core responsibility to start task and run service as a container. When your service becomes container, it is called task. So worker node just do that. Okay, next is uh, service. Okay, definitely when we create a service and assign to manager node, then definitely manager node uh, do the rest of management. A service defines how to run a specific task or container in the swarm. Okay, when you have small number of container running on different nodes, and then service define how to run specific task, because that service is assigned a task, and that task explain the instruction where to run this service as a container. Okay, when you deploy a service, Docker Swarm creates and manage the desired number of replicas across the nodes. Replicas mean you can run more than one instance of your service. Let's suppose you are going to create one instance of your service. Service is just authentication server. Okay, and you want, okay, there must be two authentication server. If there is one down, another will be up to make the authentication, and there will be no downtime or any issues with the service. So when you create service, you can also provide number of replicas with the same time. Also you can again increase or decrease. So task, next is task. A task is a running container managed by Docker Swarm. When your container, when you deploy a service and it start running container, this becomes a task, because a manager node assigned a task, okay, run this service as a container. Each task corresponds to a service instance and it is assigned to a worker node. Okay, got my point? It's saying that each task corresponds to a service instance. When you deploy a service, a task is assigned to that service object, and it is also assigned to for which worker node you will be running. Again, another important term we have, swarm. For beginners, it is difficult to understand what is a swarm. Is a cluster of Docker nodes. Okay, let's suppose you have Docker nodes. As I see, all these nodes are called one cluster. Okay, and when you start running all these nodes in a swarm mode, it becomes cluster. Simple. This cluster can be created by initializing a single manager node, which can then be joined by other manager or worker node. First of all, definitely you have EC2 instance or virtual machine or any your local machine, even you will start running Docker daemon, Docker engine, and then you will create a, then it's up to you. You are going to make that your node or manager or worker. But remember that worker cannot be live without manager, but manager can live without worker. And these can be promote and depromote. Manager can be worker, a worker can be manager. Okay, so another important term is overlay network. Docker Swarm uses overlay network to enable communication between containers deployed across different nodes. Okay, well, let's suppose your one authentication server is deployed here, your user account service is here, your registration service is here. To make the communication among these nodes, you must specify your network overlay network. Okay, actually this abstracts the network configuration, allowing container to disclose and communicate with each other. Okay, so regarding architecture, you must know the control plane managed by nodes. A control plane is responsible for maintaining the state of swarm, scheduling tasks or work nodes, providing APIs, handling cluster management such as scaling and updating the services. Okay, so let's move to the actual work of this video. We will be creating three instances, EC2 instances on AWS, and then we will make one instance as a manager node and two instances as a worker node. Then we will deploy our services on EC2 instance, and then we will try to access those services. So let's start with the actual implementation. Okay, guys, to create a Docker form, first we have to know the prerequisites. That prerequisites are, we must have at least two or three nodes, because we will need one manager and rest of worker nodes. So because I have my local machine, and here I cannot create more than one node, because I have one Docker engine running on my local machine. Definitely I will introduce the commands, how those commands we can execute. But for now I am going to create three instances on AWS. This video is useful for you so that you can also learn how we can create instances, EC2 instance on AWS. For that you must have your login account, because I have my free tier account, and we might have some restriction, but whatever restriction we will be receiving, I will let you know. Otherwise, let's see what happened. So first of all, I have to log in with my user account, and here I have to provide password. I don't have sign in as a root user. Okay, and because you have to see that I have to provide 6P362G. Let's see if it works. Otherwise, okay, great, it is working. So I have to provide password again. Now I will be routed to Amazon dashboard, where I will be able to create a number of services provided by Amazon, like VP, virtual private connection, EC2 instance, identity and access manager, whatever S3 service. So right now, because we need three instances, we can also create S3, but this is purely for storage of objects, and we need some node. And here you can just go and start launching instance. Guys, here is the number of instances you can create. So you can create one by one, and you can also create three instances at the same time, because I'm going to create three instances at the start, and then later on I will divide one as a manager and rest of two as a worker node. So I'm not going to give any name right now. And here you can also select any operating system you want. You can also use Amazon Linux, you can also use Ubuntu, whatever you want. So I'm going to use select this one, Amazon. And here you must select your free tier eligible. You can see here you have two types of EC2 instances. I'm going to create AMI images. Okay, and then you must select your free tier eligible instance type. And guys, you don't need to select this option key pair, because without key pair you need to connect. Otherwise you have to download your public and private key, you have to connect with that. So this mostly we use whenever you have some different environment. So to just create three instances, here is the rest of guide. You can also, this is the configure network settings, because if you want to create new security group, and you can also use the existing one. With new security group, I want to allow SSH traffic from anywhere. I want to allow HTTPS as well. I want to allow HTTP traffic from anywhere. So 000-0 mean anywhere. Otherwise you have to mention from which IP you can just log in and communicate. So then we have configuration storage. One thing, guys, I must show you. because I did not select subnet. Okay, for that you must because you have virtual private, but you did not. If you are not going to select, it will be used by default in any available zone. So okay, I'm not going to select it. Let's see if I can use by default. Otherwise, I can configure later on. Okay, then we have mm, configuration storage. I'm not going to change any because I don't want to be charged. And here is advanced settings. In here, you don't need to select any specific option, but you must go and provide the configuration parameter here. Here we have some information to start running when our instance will be created. It will install some updates, and it will also uh, mm, create some information like okay, this is regarding Ubuntu, and then I have to select the instance type uh, Linux. Okay. Okay, so I have changed my operating system to Linux because it is also available for me in free tier, so no worries. And then again, I have to check all these because I can connect with the HTTPS, HTTP, and SSH. Because SSH I will use to log in to CMD, and I will use some commands regarding assigning node, creating node, and joining node, all of these. So then we have these commands to be run when our instance will create. It also enable Docker. It will install Docker, and then it will start services. When this will start running Docker, it will become our node. Okay, so we have mentioned that number of instances 3. Okay, great. So let me launch the instances. It will take a while and it will create 3 instances for you. Okay, successfully all these 3 instances are created, and you can just go into the instances and see. Okay, these are going to initialize, and here you can just set it is my manager, and I want to make I just naming it because later on I will do commands on these nodes accordingly. So this is worker 2, and this one is worker 1. Okay guys, so it is good to know that you have created your 3 instances on AWS by covering Docker Swarm, and now let it to be initialized, and then I will start connecting with it. Once your instance get initialized, then you can connect and start few commands. I will show you. Another thing in the meanwhile, let me share you. You can also set your security. Here is your security group, and here you can see what your security group have the option. Because regarding inbound option mean from outward to in your instance, how the anyone from publicly connect your instance, you have allowed. You can see here that all 3 instances, sorry, all instances. Let's suppose you have a security group having allowing HTTP, HTTPS, SSH. So it does not if I add it and show you in detail, here you can see anyone can connect because it is 00 with your instance through these protocols. Okay, rules with source this allow all IP addresses to access your instance. So this is a good thing. You also can see how we can configure and create security group and assign. Okay, I have also different session working on all of these options on my channel. You can go and see how we can set outbound rules, how we can set inbound rules. Okay, everything I have provided. Regarding outbound rules mean from your instance to public, uh, everything is allowed. Okay, And then we also have your you must know your uh, virtual private network. Let me show you as well. Here is your virtual private. Here is your subnet. Actually, this subnet should be publicly allowed, and with this subnet, you will be available. Here you can see block public. You cannot connect your instance if it is a publicly block. Let me show you as well. So back to our dashboard, and you can see that you have created 3 instances, and these are all past your. There is no issue with your instances, and you can uh, directly connect. Let's suppose I want to connect with manager. Here you will select this one, and then you will be having action connect. And from here, associated subnet is not public subnet. It is showing warning that you cannot connect until unless you have your public subnet task. So for this, I have another video under AWS Cloud Practitioner session. You can go and see how we can change it to public subnet. Okay, because if I will try to connect this instance, it will not allow me, and it will show error. Here you can see your instance is not able to connect. So for that, for rest of command, how we can connect, how we can create manager node, how we can join other worker node with the manager node, because uh, if you see in this diagram, we have created one manager node and 2 worker nodes. Okay, we have 2 worker nodes, one manager node. Once we create all of these, we have to join these nodes with the certification created with this manager node. Otherwise, this manager node will not know what are these nodes. This will never manage all these nodes. So how to do this? Let me show you how we can do this practically. Okay guys, I have found a great tutorial for you because I'm not doing it myself. I want you to do this and let me know what the challenges and issue you found you face. First of all, when you will connect your any node, because you we have created 3 nodes. One is, and naming it, one is manager and 2 are worker node, worker 1 and worker 2. So far you will definitely connect with your manager node, and you will start docker swarm init. It will initialize, and it will show you the uh, output as below. And then here you can see you have this certificate generated, token generated. Because when you will try to create, because you have created worker node, and when you will try to join those worker node with this manager node, you have to run this command. So here you can see joining docker swarm nodes, copy the token from above step, and run in the swarm node 1. Then you will connect again with node 1, and then you will run this command. And after this, you will connect to node 2, and you will execute this command. After this, create a task in the docker swarm. So you would then, because you want to deploy service, and your service name is this. Okay, and you want to run this service on the port this, you already learned how to run docker command. After this, you are going to create service, and there must be an image available. Even if you have local image available, then you will definitely write this command, docker service create, and this you will name this service, and here is the image name. It will search on your local machine, otherwise it will go on docker hub. If you have this image on your docker registry, let me show you. Let's suppose I have docker hub. Okay, and here I have repository, and under repository I have this image available which is publicly available. So in place of this I will just write this command, this name. So it will automatically download and run this image as a container and with the service name whatever we provide. After running this, you will create a replica so that you can have more than one images running, more than one container running from this image. So here you can just create Docker service scale. It is scaling from 1 to 4. So 4 services will be available here. So I'm not doing myself because I want you to do this. If you face any issues, then definitely I'm here. I will provide you help. And after running this, from this is the IP of your node. Let's suppose if you have EC2 instance IP, let me show you. Here you can see, you can note your public IP of your EC2 instance. Okay. Here you can note this, and then you will be providing here, and then you will provide HTTP port what you are allowed, then you will be here able to access your application. So if you will not be able to do, then definitely I will create another session, otherwise it is good to go. Okay guys, how to do on your local machine, how to make your local machine as a Docker swarm. So it is a very simple, just you will be providing Docker swarm init. Okay. Now you can see, to add worker node to this swarm, run the following command. Okay, swarm initialize current node. Your this node is now a manager. Okay, to join another node with this manager node, we have to run this command, because on my this machine I have single node, because I cannot run more than one Docker engine on a single machine. So for that I have to have another machine. I can create virtual machine, I can also create some EC2 instances as we have created on AWS. So to do this, just I will run this command, and then I will be able to run Docker Swarm. But for now, because I'm going to use this manager node as a worker node as well, and I'm going to run the service and show you how this works. To just check about the Docker Swarm, you can also use Docker info command. It will provide you all the details as well. And then after this, you can also check how many, you can see here everything is provided about the uh, let me show you what is the state of swarm. Here you can see your swarm state is active. Okay, and now your it's a node ID and manager node, and here you can see, because we have single node and it also a manager node and node. To check the number of nodes on your console, we have also, sorry, another command where I can just write docker node ls. It will provide you the detail of your node. So we have one single node available, and that is manager and worker as well. Okay, after that, in order to add worker node to swarm, you can enter the command I already show you. Okay guys, just for the demonstration purpose, I am going to use hello world image we already have on docker.com. To do that, I will just write docker, because I have a single node which is manager node. I am also deploying service on this manager node, and it will start working as a worker node. Docker service create. You can also provide replica, but right now I am going to provide nothing. Hello world alpine. I don't want to provide version. Ping docker.com. Here you can see 0 out of 1 task. It is preparing actually. It will start downloading hello world docker image. Okay, and it will create that service as a container. Service this is uh, converged. Okay, then I can verify the services as well. To do this, I have also one command, docker ls. Sorry. Here you can see we have successfully running our hello world on our manager node, and there are also some replicas. Uh, Already services are available, but you can see that we have successfully uh, deployed hello world on Docker. Okay, guys, in this session, we have learned how to create manager node, how to create worker node, how to join these worker node with manager, and then how to create replica, how to access this worker node with the URL. So, how under the hood, how it works. Here, I already explained you how it is work. In last session, you can go and watch the video for more understanding. So this is for Docker Swarm, and this is the last session of our DevOps tutorial 3, because in this session we promised that we will cover Dockerization, containerization apart from Docker Swarm. So rest of the videos on Docker Swarm you will keep watching. I will provide separately. To close this thread, this was the last session, and let's see what is the next session in our pipeline. Here you can see that we have covered programming languages. We have decided Angular, Java, and other supported languages. Operating system, we have covered Linux and Linux, Ubuntu, and Windows. Terminal knowledge, we have covered CMD and PowerShell. Apart from Windows commands, basic Windows command and Linux commands. All tutorials we have on our YouTube channel. Then container, we have covered all related to containerization, and today it is our last session. And then in next session we will see what is and how to set up X. So let's see in next section what the possibilities we have to set up for the X. Okay, please subscribe my channel if you are not subscribed yet, and also do like, share in your circle these videos, and also provide your valuable comments. And I hope you will be liking and sharing, so that I will be continuing with rest of the technologies and tools sharing with you. Thanks.